Welcome to all. I'm a coach coordinator of digital system design. Today we'll discuss about the what is meant by system, what is meant by signal, and we know the difference between the analog signal and digital signal, and we'll see that there are some examples for the digital systems. So what is meant by a digital system? So before going to the digital system, what is meant by a system? So we all know that solar system is a one system, school system, family is also a one system. Familiarly, we know that computer is also one system. So what is meant by a system? A system is a set of elements working together to achieve a common goal is called a system. So it means that we are giving some inputs to a system, we will get some outputs. We work together to achieve some common goal. So system is nothing but it is a set of elements. We are working together on that goal to achieve that goal. So this complete process is called as a system. So what is meant by a signal? A signal is a function that represents the variation of a physical quantity with respect to any other parameter. So signal is a one function that represents the variation of the physical quantity. So it is representing the variation of the physical quantity with respect to any other parameter. So let us consider a clock. So here, sorry, here we are, the time is an independent variable. So here, let us consider the signal. Here, the voltage is varying with respect to time. So here, this is a signal. The voltage is a signal that is varying with respect to time. At this instant, it is having some magnitude. At this instant, it is having some magnitude. At this instant, it is having some magnitude. So the varying parameter is voltage. The voltage is varying with respect to time. That when time changes, the voltage is also changes. So this is an example for the signal. This is in a time. So this is an analog. This is an example for the analog signal. Analog signal is any continuous signal varies with respect to time. The digital signal is a discontinuous signal which varies at the discrete time. So this digital signal is a discontinuous signal. This is not an analog signal. Here we saw an analog signal. It is which is in a continuous signal. We will get a magnitude of the signal at any time instant. But in a digital signal, this is not a discrete analog signal. This is a digital signal is a discontinuous signal which varies at a discrete time. Discrete time means at time instance we only will get a signal. At T1 it is a magnitude, it is having a magnitude of 5. At T2 it is having a magnitude of 36. T3 it is having a magnitude of 21. At T5 it is having a magnitude of 45. Between T0 to T1 we won't get any signal. Between T1 to T2, we won't get any signal. So here is a discontinuity. So this is a difference between analog signal and discrete signal. So digital signals are stored the information in a form of zeros and ones. So we'll represent a lower zero as a low level signal, one is a high level signal. We'll represent the signal with the help of two digits only. That is in a binary signal, we'll represent a signals in a two form, either with a 0 or with a 1. So 0 represents the low level signal, 1 represents the high level signal. So all signals are analog in nature. So we have to convert all signals into a digital signal to process the signal in a digital form. Nowadays we all using digital systems, so that we have to convert that analog signal into a digital signal to process the signal. So to convert that signals into a digital analog to digital, we will use an ADC, analog to digital converter. The ADC it converts the analog signal into a digital signal. DAC it converts the digital signal into a analog signal. So that is an that is a circuit you convert an analog to digital, convert a digital to analog. So we'll see, when you speak in front of a mic, it is in a physical quantity. that is a physical quantity that will be converted into a electrical signal by using a microphone that will be available in a form of analog signal. So to process that voice signal, you have to convert this analog signal into a digital signal. So to convert that signal, we are using a ADC, analog to digital converter. So here after the ADC, we will get in a digital signal that will be processed by the digital system. Then that will be converted into a analog signal by using a digital to analog converter. Why? Because here a speaker will take an analog signal to produce an actual output, so that we have to again, after processing, we have to convert that digital signal to analog signal to give the output to a speaker. So that is a conversion from analog to digital and digital to analog. So what is meant by a digital system? The digital systems are nothing but an electronic systems which uses a digital signal. So we all know that the personal computer, digital calculator, digital watch, digital weighing machines, digital voltmeters, all are as nothing but a digital systems. These systems will take in a digital signal. The uses for the digital systems are we'll use the digital systems in business, commercial, education, and medical treatment and specific developments. So the so before coming to a digital system, how can we form in a digital system? So first, we'll know that silicon from that to form an integrated circuit. Before going to the form an integrated circuit, we go for an how this evaluation comes from. So we all know that first we know that semiconductors is the first era. Then by using the semiconductor materials, we can we manufacture the diodes, transistors, and as any other circuitry. So before, after the semiconductors, we know the switches. By using the switches, we can count switches. Then by using these materials, mm, we can manufacture the integrated chip. So number of after this integrated chip era, we gotten a number of integrated chips. So by using this integrated chips, we can construct in a circuits. All together, the circuits will come into a digital system. So these are the advantages of a digital system over an analog systems. The digital systems are easy to design. The digital systems provide more accuracy than an analog system. The digital systems are less affected by the noise. The digital systems are very reliable. Digital systems are low cost compared to the analog system. So with the from this presentation, we know that what is meant by a system, what is meant by a signal, what is an analog signal, what is a digital signal, what is in a digital system, what is an analog to digital converter, what is in a digital to analog these are the new things to you. From this presentation, you learn all these things. Thank you.